So, I guess the first obvious question is what in the fuck are we looking at? Well, these are your typical make-pack welds. Now, on all of these, the current setting is the same feed rate, same voltage setting on the machine. But how did I get three different welds without changing any of the settings? Well, the answer is simple. I played with the line voltage, which most people can't do. Like, I'm a weirdo, so I happen to own things like a 3,000 watt variable voltage transformer. So, what do we have here? We have an example of how a weld pack transformer, one of your cheap 110 welders works. Now, this doesn't apply to inverter welders, because if you get a MIG wire feed, even the cheap ones that are inverter, they have something called regulation. These welders don't have shit for regulation. The old transformer machines, or they're still making them. You get these at the Home Creepo. Basically your Tashiti Lincoln weld packs, as they are, right? And if I had it to do again, I would have bought the fucking 180 because it runs on 220 volts and it's a lot more of a stable machine. So don't ever do like me and buy one of these fucking piece of shit transformer machines, even if they are a good name brand. But anyway, I digress. Back to what we're talking about originally here. So, same machine, same settings, didn't change anything on the machine. Same shitty welder, hovering over here with a shitty torch with some 30 thousandths L56. And I'm a cheapskate, so I don't buy any of that fancy mix gas. Actually, strangely enough, I had a helium tank that I filled with carbon dioxide. I just transferred liquid carbon dioxide into it because, well, it's a small tank and I wanted to drag the fucking thing around. Didn't want to drag around a 20-pound CO2 cylinder. So, even though that says helium on it, I was welding with basically CO2. So, let's get back to the bit at hand. So, what are we looking at here? So, we've seen examples of 5 welds, right? Now, if you really want to see the effect of this, we take this and here's the same 5 welds. I did this to accentuate how bad this effect really is. Now, this is with the wire speed cranked up a little bit, right? So you can really see right here. See, this one is 105 volts. Now, when I mean 105 volts, I'm talking about the line voltage at your house, right? So this welder is designed around this voltage here. Now, here in lovely fucking Landers, California, my line voltage runs anywhere from about here to somewhere up to here, rarely up here. Like if it's the summertime and all y'all are out there running your frickin' AC units and your swamp coolers and all the other happy jazz, I am lucky to see, like, in the midsummer, sometimes I don't even see 105 here. Like, the voltage out here just sucks. So, in the summertime, or when everybody is cozy in their house running electric heaters, this is the kind of shit that I get off this welder in the best case. Is it doesn't produce enough voltage on the low side. So if you're not like me and don't understand a lot about how old school shit works, there's a big iron core transformer, and they work on a ratio of turns. So you have a transformer which has got a big iron core like this, and then on the 120 volt side, you'll have, say, 10 turns. Just for the sake of math. So if we have 120 volts going in, and then on the secondary side, which would go out to your welder stinger, let's just say we have 1 turn, right? So simple ratio, we would go from 120 volts to 12 volts, right? Well, in this case, it's more like something 120 to I think for these machines, they run somewhere between 18 and 21 volts, something like that. But you get the idea. So the voltage in and the voltage out are directly proportional, right? So for this process to work right, you need a stable output voltage. But if you don't have a stable expected input voltage, your output voltage is going to be lacking. Now, this type of wire in this machine, this is done at the peak current setting. So anytime you're, this machine would probably be fine at 105 volts if I was running something like 22 thousandths wire on a much lower current setting, so expecting a lower voltage, or I could compensate by a higher voltage setting and then get the lower voltage target that the wire would need for the thing I'm loading. But I don't do a lot of thin stuff, so I'm always trying to run, something like 1/8" plate. So when you're trying to run 1/8" plate, or anything like your standard tubing, or stuff like this, like 120 wall tubing, or something that a lot of people are always trying to weld with these machines, you are playing the Edison lottery, right? So this right here is going to determine the outcome of your weld. Now, this is how I did this. Now, this is probably going to be my cheating method from now on. It seems that at 105 volts, which is where I end up most of the time, this welder can't do shit on the upper voltage setting with the big wire on thick plate. There's just no getting enough voltage to run this wire. So at 110, it starts to, the welds, they start to fuse, right? And this is pretty much the optimum wire feed setting that I could find in this, for this wire, the gas I'm using, and the thickness of the plate. So the plate's absorbing a lot of the heat energy that's coming out of this welder. So right around here at 110, you go from 105, which is more or less completely fucking useless. Like, I think a lot of you are out there thinking you're dumbass welders and you just can't fucking do it because you get this. And it's not you, it's your machine if you have a transformer machine. Again, like I said, if you want to avoid this problem, get an inverter-based MIG machine. Especially if you live out here in the middle of nowhere like I do, and your voltage sucks. Heck, even if you live in town, your voltage could be shit too, unless maybe you're next to a substation or something like that. So it helps to get yourself a multimeter and check your line voltage. Plus, the same thing happens on an extension cord. I mean, you could have a perfect 120 volts at the wall and then plug in, 100 feet of some shitty 14 gauge or even a 12 gauge extension cord, and then as soon as you fire the arc, you could get probably in some cases, if you're at the peak current settings, these welders are running like a full 20 amps, right? Peak, right? They need a full 20 amps. So by the time you pull 20 amps over the resistance of this wire, I mean, you could end up, dropping the voltage, up to 15 volts. So, once you drop the voltage up to 15 volts on the end of this extension cord, you get this. Also, if the wiring from your garage to your power box is 14 gauge, you're gonna end up with the same problem, because you might have 100 feet of 14 gauge wire between where you're welding at the monkey face plug in your house to the panel. So you can get the same fucking voltage drop down to 105 volts. Now, if you're starting off, say in the summertime when everyone's got their air conditioners going, you get 105 volts in. I mean, what do you get out? Like, you're trying to weld with 95 fucking volts. It's just not going to happen, right? So that's the first thing. So now this is optimal right in here. Like, you start getting into the sweet spot at 115 and 120 volts. Now I kind of went off and I did a cheat, right? So since these machines aren't very good at this type of plate, and then the gas I'm using, CO2, it tends to pull more heat out of the weld. CO2 absorbs quite a bit of thermal energy from the weld, and it's good at carrying the thermal energy away. So if you start looking at these profiles, and you got there doesn't appear to be a lot of difference between 120 and 125, but if you look at the appearance of the weld at 125, it's just getting a little bit more energy in there. It's getting a flatter profile, same feed rate. This would be my preferred weld for this particular wire on this kind of material right here. This isn't too bad on. This wouldn't be too bad on thinner material. But that's your sweet spot. These welders want to be right at 120 volts. So that basically demystifies the reasons why these things weld. And like I said, back here on this plate, I mean, here we have this is a higher feed rate than this side. I just wanted to accentuate how the effect is of voltage. So here's the same heat setting, right? So we have the same 5 voltages, but with a I think it's like on this welder, I'm not sure if it's in feet per whatever. This welder just kind of gives a 1 to 10, so it's like the difference is like a 2.5 and a 3 on the wire feed speed for this welder. I don't know if that amounts to anything like inches per minute or feet per hour or whatever rating they'd want to use. But here we are with the 105. Like, you can really see, like, at 105 volts, there's just not enough voltage to get any heat down, and this couldn't even make a weld. Then we go up to 110, and then here we still get this real shitty bird poop, right? Because we don't have enough voltage to burn the wire and get the heat into the plate at the speed that the wire is coming in and absorbing the heat. Now we get to 115 volts, and it starts doing something, all right, but it's still not acceptable. And here we are, again, 120 volts. We get an acceptable weld, and now look, just that extra 5 volts, and we're like right at magic. This is sort of comparable to the 110, 115 volt weld at the more appropriate wire speed, but you can start to see it really wants to lay down. It started penetrating, got uniform. So voltage is the key. You need to correct your voltage if you have a transformer machine. And like I said, the inverter machines, I think if they're any good at what they're doing, they should be correcting this voltage for you and have good output regulation. So that's just something I kind of like finally hit upon. Just if you're gonna go MIG, and if you're gonna go like a weld pack MIG and cheap MIG, make sure you get an inverter machine. Now there's some downsides to inverter machines. The inverter machines, they don't last as long as a transformer machine. The one thing I can say about this transformer machine is unless I dip the fucking thing in salt water, throw it off the back of a truck, and then plug it into 240 volts directly, this machine's probably going to be around, and that transformer is going to be good by the time I'm an old man dying of a heart attack or something. Now, if I get an inverter machine, or you get an inverter machine, that thing might not be around to see your kid get out of high school. Like, the inverters, there's a lot of moving parts inside of an inverter. They have capacitors that go bad. They have IGPs. I mean, there's probably, the parts count in those things is staggering. It's probably got to be thousands of parts, and probably somewhere in the neighborhood of 10 to 20 main parts that are really hanging on line voltage. So it's up to you, but I'd say the key to making these 110 volt MIG welders work is get the inverter welder. These transformer welders, they're too affected by wide variations in line voltage, and even at the proper line voltage, sometimes my voltage will sit right here, depending on the time of day and the use case. If it's during temperate times of year where the outside temperature is right around 60. Nobody's running a heater. Nobody's running an air conditioner or a swamp cooler. So the line voltage comes up to where it should be right here. And then I get these two weld profiles, which isn't bad as long as I'm not on the end of extension cord. I get this actually. This is actually on the end of 150. Yeah, this is on the end of 100 feet of extension cord, but the extension cord that I use is 8 gauge, so there's really no voltage drop. So it's really important if you do use an extension cord with these transformer machines that it be really, really thick wire. 8 gauge could easily carry 50 amps on each leg, so with very little voltage drop, and we're only targeting 20 amps. So if you need to run long, you need a big fat extension cord. Now I don't run my cord to a wall outlet either. I run my cord directly back to a power panel and then tie it in with a breaker at my power panel, and then when I'm not using it, I pull the breaker out of the box. So yeah, it's basically like a drop cord, bam, right into a breaker. And that gives me direct home run power whenever I need it. So, there's no chance of having these crazy voltage drops from like 105 to 95. If you want to see how I accomplish this test, I'll show you. It's not too particularly difficult. Not a lot of people have these laying around. They're starting to actually get rare. It's just a variac, it's basically a big variable transformer. I believe this one's somewhere in the 20 amp rating. Yeah, so this one's rated at 20 amps, so that's somewhere around 2,500 watts. So this is an appropriate transformer for making voltage adjustments. And no, excuse me, I could probably use this transformer for years welding like this, making adjustments to compensate for bad line voltage. But not exactly an ideal setup. This particular welder is one of my biggest regret buys from years back. So don't ever make that mistake again, for me, and I recommend you don't ever make it either. Anyway, have a good one.